3.
Hi, we're Team C3375A, the Comets, and this video is for the VEX Create US Open at Nationals. My name is Ashley, I'm the captain of the robotics team, and I worked with computer programming and recording in the engineering notebook. I'm also a sophomore, and I aspire to become a biomedical engineer in the future.
Hi, my name is Mariah, and I'm also a sophomore, and I did electrical and the wiring for the team, and I also did a book.
Hi, my name is Angelique. I'm a senior. I worked on the mechanical for Robot A, and as well as the CAD/CAM design. I aspire to be a mechanical engineer.
Hi, my name is Angelique. I'm a sophomore. I worked on mechanical for Robot A, and I aspire to be a biomedical engineer.
Hi, my name is Casey. I'm a sophomore. I worked on mechanical for Robot A, and I hope to be a mechanical engineer also.
The most difficult task in building our robot was
The gear train, because in order to let the gear train go up and down and bring the vacuum cleaner and out, we need a total of 3 motors for the gear train alone and a motor for the vacuum pinion. This was also a good feature, but it gave us difficulties to find the perfect meshing for the gear to have torque. Also, another great feature was the plexiglass, because it's lightweight and it allows us to push the stars without having any wobbly or difficulties. It gave us trouble because we need to find perfect measurements in order to fit the vacuum pinion without it sliding out. Another great feature that we had was the triangle shape, but since it's not the square design, we only have a certain amount of space to work with, so in order to turn, we need to program it differently.
I consider the strength of a robot to be the shape of it. We are one of the first and few teams who attempted to make a triangle robot. We also gained awards like the Innovative Award, Creative Award, Design Award, and the Judges Award.
I think to improve our robot, we could work on our driving technique. In the past, we've been more of a defensive team, as in we block stars coming to our side. But in the future, we're striving to be an offensive team and pushing stars to the other side in order to gain more points and further our improvement in the game.
To help others in our community, we reached out in New Rochelle to teach children about simple gear trains as well as the importance of STEM awareness in our community. We also brought some of our robots from last year's competition as well as a few claw bots, and we had demonstrations, and we also let the children drive them. We will now show you some pictures from our engineering notebook. These 2 pictures were our model pictures as our inspiration for the design. As you can see in the middle, there is no tension among the frame of the chassis, and it's built very simply yet efficiently, which is what we were really aiming for. Also, we were really looking at the even weight distribution on both sides as well as the heavy component in the middle. This gives this plane weight, but it doesn't make it too heavy. These are some pictures of when the girls were tightening the wheels and as well as the chassis. We decided that we wanted 2 layers so that way we can get up to the 25-inch bar. These gear trains have a 1:1:1 ratio because all of the gears are of the same size. These are also 1:1 and they have 100 RPMs. This is our programming. We use the operator control because we had a wired motor controller, and the motors had to be plugged into ports with 3 prongs. However, the motors would move autonomously during the driver control, so we had to fix that, and we used an RX motor control for that. We used the 2 joysticks when we moved vertically to control the wheels, and we went sideways to move the wheels left and right. That's our code. These are some more pictures of fixing the wheels. And the tangent of 70 degrees is a radian of 1.229, which means that the lift and claw is going to make a revolution with the 5-to-1 gear velocity.
Now we will show you how our robot drives. This is how our robot drives in autonomous mode.
As you can see, Angelica's driving the robot backwards and forwards. We use this as to get our momentum to knock the stars off the highest bar.
As you can see, we knocked both the stars off by trying to turn the robot to hit the stars.
And with a different format of the gate, we're hoping to make it work better than the one we have in our lab.
We will now show you some of our CAD/CAM programming that we use for Robot A. We will also show you some of the programs that we wrote as well for this robot. So this is the CAD/CAM for A. What we did was we used the 2D sketch feature to draw the shapes, the two triangular shapes, as well as the rods. We also tried to draw the gears as well for the upper gear train that shoots out the rack and pinion.
As you can see, the lift, plexiglass.
We also used these to draw the C panels of the wheels. We had a little bit of difficulty with this, getting the proper measurements, but once we figured it out, we were able to utilize this to make more creative decisions for our robot. And yeah, this is also our first year ever using CAD/CAM.
Another one of our projects was using Cubify. And these are some designs that we tried to make. So this was supposed to be like a cake dish in the 3D printer, but as you can see, we had some problems with it, like the heat. So a lot of these got melted. As you can see, this was supposed to be a claw, but it collapsed. So we definitely would like to see if we can work more with the 3D printer, but if it can be successful.
One last thing we would really like to show you is the awards that we won this year. This year we won the Create Award, Judges Award, Innovate, Design, and Judges again. So we won these awards because of our triangular design. We picked the hardest design because not only is it unique, but we wanted to challenge ourselves as well, to work ourselves to our fullest potential.